Hello ladies and gentlemen, today we are going to look at how earthquakes are generated, tectonics and fault behaviors. So a brief introduction to plate tectonics and fault generation. We have three types of the tectonics that occur, that is the convergent plate boundary tectonics, we have the transform plate boundary tectonics, and we have the divergent plate boundary tectonics. As you can see from this image, at the transform plates, we have two tectonic plates rubbing or experiencing what we call shear force against each other. Then at this point, we have the divergent plate boundary where the different plates are experiencing an extensional force causing them to pull away from each other. Then the next one, we have the convergent plate boundary where the plates are undergoing collision. Then they have the compressional force causing them to collide with each other. All those behaviors, for example, are the transform plate boundary, divergent and convergent, result into a release of a certain amount of energy, which is responsible for causal earthquakes, as we shall dive deeper into this information. Then, before we go further, let us also introduce a fault and different types, as we have already introduced the plate tectonics. So, we have different types of fault. We have, for example, a fault can occur, for example, when there is a relative movement between two blocks, for example, a footwall block and a hanging wall block, as shown here, when they undergo relative motion as a result of the different movements that arise as a result of the different plates and the different boundaries. So there we also have the experiences where we have fault zones. Then there are different blocks are caused to behave differently as a result of energy exerted on the earth. So the different types of faults we have, for example, we have a normal fault, as you can see from this image. We have a hanging wall block and a footwall block. For a normal fault, a hanging wall block moves downwards relative to the footwall block. And this type of fault is common in the divergent plate setting, and that is now as when there is, for example, under divergent plate setting, the hanging wall block will be constantly downward relative to the footwall block. Now that we are trying to relate what we have seen before, the plate tectonics, and how it causes the different behavior in the different fault zones. Then we have also the reverse fault. Reverse fault is one that is common now and the convergent plate setting that causes the hanging wall block to move up relative to the footwall block, as shown from this, the arrows that can be seen from this. Then we also have the other type of fault is the strike slip fault. In the strike slip fault, we have the left lateral fault, then we have the right lateral fault. As you can see, we have the sinistral left lateral movements are shown here, then also the same here for the dextral fault, which is also the right lateral. The right lateral is where now the hanging wall block will move in the right hand direction. Then the left lateral, in the sinistral, the hanging wall block will move in the left hand direction relative to the footwall. How tectonics and fault behavior cause an earthquake. Before we do that, you have to first of all look at the structure of the earth. The earth in itself is not a perfect sphere, and then the earth is divided into three different units, whereby we have the core, we have the mantle, then we have the crust, as shown in this diagram. Movement always occurs on the Earth's crust in the lithospheric plates that are on the Earth's crust, and the energy that causes the movement of the plates resulting into plate tectonics. In simple terms, plate tectonics is just motion of the different Earth's lithospheric. The energy that causes that movement originates from the mantle, and that energy comes as a result of convectional currents that originate from the molten rocks that are within the mantle that causes, for example, a divergent plate boundaries. There is separation of the plates as the mantle plume rises, and energy causes the plates to move apart in different directions. So that results into, for example, volcanic eruption. Then at different sections, these mantle plumes, as they behave, they cause different kinds of behaviors in plates. And at one section, there's a separation of plates, divergent plate settings, resulting into formation of volcanic mountains. Then at another section, we find that there's a collision that occurs, that is at convergent plate settings. Now, at that collision, the behavior of all the structures that are formed is totally dependent on the density of the plates that are colliding. For example, if a denser plate is colliding with a less dense plate, the denser plate will sink deep, will undergo what we call subduction. But at the sections where the collision occurs between plates that are almost of the same density, there is always formation of hills and mountainous features. So we are going to dive deep and see how the different shocks that causes earthquakes originate. And as we have seen before, that the generation of faults totally depends on the behavior of the different plates as they move at the divergent, transform, and convergent plate settings. So we observe that meanwhile the faults are already formed with the earth not being stable and those different plates are always moving, there is always frictional force that is generated at the different fault zones as a result of interaction between the different blocks, the footwall block and the hanging wall block. That interaction builds up with time as the energy, as the forces of collision or interaction of different plates occur. So there is a build-up of energy at the point of contact, and frictional force results into build-up of energy and reaches a point whereby the forces are able to overcome the frictional force, and that results into the generation of an earthquake. Noticeably, 4 shocks occur, giving indicators that an earthquake is going to occur in an area, and so therefore we can be able to detect and know that an earthquake is going to occur. And the point where the earthquake originates from in the subsurface is known as a focus, or we can call it the hypocenter. Then a point just above or vertically above the focus is known as the epicenter, and that is on the Earth's surface. That can be used as a reference point to know where the earthquake originated from. This is done by different seismologists and geologists. So thank you so much for watching this video, and don't forget to subscribe.